Okay, so good afternoon. My name is Larisa Mocanu. I'm a PhD student from Cassino, Italy. And the work presented today is focused on the effect of recycling on internal and external defects of titanium powder particles for the electron beam melting process. So the electron beam melting process is part of the powder bed fusion category, where as material feedstock, they use the powder, which is previously atomized. And after the printing process, the powder which is in excess may be reused in order to lower the production cost. In this work, we wanted to understand which is the effect of this reused powder and which are the differences between the reused powder and the virgin one. So in this work, we analyzed 2 batches of powder, and we made a comparison between them. And we analyzed the morphology, the external imperfection, and the internal characteristic. And at the end, we provided also some quantitative evaluation using a commercial software. So more in detail, in this work, we analyzed 2 batches of titanium powder particles. The first batch is a virgin powder, which is plasma atomized. And the second batch is a powder which is recycled more than 100 times. Here below, there is the chemical composition of the 2 batches of powder. And here, as can be seen, the percentage of oxygen is increased up to the limit according to ASTM. Here there are the 3 evaluations which were made in this work. So we analyzed the morphology, the external defects using the scanning electron microscope. And then for the internal investigation, we embedded in resin some few powder particles. And then we polished this resin sample for the optical observation. And at the end, we used the ImageEye software to provide some quantitative evaluation. So here there are the comparison between the virgin powder and the recycled powder from the same observation. And here an interesting result is the almost completely disappearing of all of these tiny particles, which are called satellites, and all of these satellites decrease the flowability of the virgin powder. So this is an interesting result for the external evaluation. Here there are all other defects which are present in the virgin powder, and they are due to the atomization process. For the recycled powder, in addition, we also have some broken particles due to the sieving procedure and some other defects which are due to the temperature condition inside the ABM chamber. Here there are the comparison from the cross-sectional view. As can be seen, the virgin powder have some internal porosity, which are due to the atomization process. And in recycled powder, most of them disappeared. And at the end, we utilized the ImageEye software to provide some quantitative values for the internal porosity. And in this case, the virgin powder have a higher average percentage of defects, which is consistent with the observation of the optical microscope. And but all of these results underestimated the actual situation, because it is not possible to say if the observed pore diameter is the maximum. So in the conclusion, we analyzed 2 batches of powder, and some interesting results are both from the same observation and from the optical observation. And regarding the ImageEye software, in this case, for more detailed testing, the microcomputer tomography results to be more suitable. So thank you.